Today, we will explore the fascinating world of irrational numbers. These are numbers that cannot be expressed as simple fractions. We will look at examples like the square root of 2, pi, and e, and understand why they appear everywhere in mathematics and the real world. An irrational number is a real number that cannot be expressed as a ratio a over b, where a and b are integers, and b is not equal to 0. In simpler terms, you cannot write an irrational number as a simple fraction. Let's compare some rational and irrational numbers. On the left, we have rational numbers like 5, which can be written as 5 over 1, 0.25, which is 1 over 4, 0.333 repeating, which is 1 over 3, and negative 7, which is negative 7 over 1. On the right, we have irrational numbers like the square root of 2, approximately equal to 1.41421, and so on, pi approximately equal to 3.14159, and so on, e approximately equal to 2.71828, and so on, and the square root of 3 approximately equal to 1.73205, and so on. Notice how irrational numbers have non-repeating, non-terminating decimal expansions. Let's take a closer look at the square root of 2, a very common irrational number. If we have a square with sides of length 1, the diagonal of that square has a length equal to the square root of 2, which is approximately 1.4142136, and so on. This number cannot be expressed as a simple fraction. Next, let's consider pi, another famous irrational number. Pi is defined as the ratio of the circumference of a circle to its diameter. No matter how big or small the circle is, this ratio is always the same irrational number, approximately 3.1415925, and so on. The value of pi never terminates and does not repeat. Now let's discuss Euler's number, often denoted as e. This number is approximately 2.718288182, and so on. It is the base of natural logarithms and appears in many areas of mathematics, including compound interest and exponential growth. Euler's number can be defined by the limit formula E equals limit as n approaches infinity of 1 plus 1 over n raised to the power of n. Let's briefly explore how we can prove that the square root of 2 is indeed irrational. We can do this by contradiction. First, assume that the square root of 2 is rational and can be expressed as a over b, where a over b is in its simplest form. This means that 2 is equal to a squared over b squared, which leads to 2b squared equals a squared. From this, we can derive a contradiction because both a and b must be even. This contradicts our initial assumption that a over b is in its lowest terms. Therefore, the square root of 2 must be irrational. Why do irrational numbers matter, and why do they appear so frequently in various fields? In architecture, the square root of 2 is used in diagonal measurements, and pi is essential for calculating circular structures. In science, E is used to describe radioactive decay, and pi is found in wave equations. Irrational numbers are fundamental to understanding the continuous nature of our universe. They are not just abstract mathematical concepts, but tools to describe our world. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.